Welcome back to Catalyst Grid. Thanks for sticking around. My name is Kingsley Amufwa. Before the first server in Project IRONGATE can receive power, 10 megawatts must be transformed and distributed. This episode is about that journey, from the grid connection point to the building's backbone. Understanding power architecture is what separates a project manager from one who truly leads. Let's walk the power from the fence to the floor. Step 1. Grid incoming supply. IRONGATE receives its primary power at 33 kilovolts from the DNO. Two circuits arrive from physically separate routes. This is the Tier 3 dual supply requirement. Step 2. GIS switchgear. The incoming feeds are terminated at the gas-insulated switchgear panel. Step 3. Transformation. Two power transformers step the voltage down from 33 kV to 11 kV. These units are rated at 7.5 MVA each, providing distribution power around the site. Step 4. AIS distribution. The 11 kV busbar distributes power to 8 step-down transformers. Step 5. Each 11 kV to 400V transformer feeds a main LV switchboard at the data hall level. From there, power flows to the UPS systems, generators, and critical cooling infrastructure. IRONGATE features two diverse feeds with N+1 redundancy at every transformation stage. IRONGATE uses two transformer types, each selected for its specific application. At the 33 kV intake, oil-filled Onan transformers stepping down to 11 kV. These sit in a dedicated outdoor compound with concrete bunds for 110% oil containment. Inside the building, we use cast resin dry-type transformers for the data hall zones. With no oil and lower fire risk, they are the correct spec for an indoor critical environment. Our oil-filled units use on-load tap changes to compensate for grid voltage variations. Now, let's break down the difference between GIS, AIS, and his switchgear. AIS, air-insulated switchgear, is the traditional, most familiar and lowest cost option. Its limitation is footprint. At 33 kV, the required electrical clearances are significant. GIS, gas-insulated switchgear, encloses all live parts inside housings filled with SF6 gas. SF6 has 3 times the strength of air, achieving the same insulation in 20% of the space. The trade-off is higher cost and environmental concerns, leading us to seek SF6-free alternatives. On IRONGATE, GIS was selected at 33 kV due to the constrained substation plot. His combines gas-insulated components with air connections, a middle ground in cost and space. Functional components like vacuum circuit breakers interrupt fault current at 11 kV safely. Ring main units allow individual feeders to be isolated without disrupting the entire loop. HV commissioning is tightly controlled. 33 kilovolts are lethal at any contact distance. Appropriate arc flash PPE, face shields and fire-rated suits is mandatory for every operation. IRONGATE's 33 kV intake was energized at 06 mag on a Sunday morning to minimize grid load. The schedule signal. Switchgear decisions must be made at design stage, not later. On IRONGATE, GIS at 33 kV was decided in a 3-hour workshop. Correct process, correct decision. In episode 11, we connect power to generators and UPS systems. Correct resilience. Subscribe, see you in episode 11.